In this video, we're going to be looking at energy stores. Energy is defined as the ability to do work. Whenever energy is transferred, then work is done. Let's look at an example of a ball being lifted through the air by the force below. Energy has been transferred from the force to the ball as it moves up. We can say work has been done. Moving on to types of energy stores. There are 8 types of energy stores that we need to know. Number 1, thermal or internal. This is the sum of the potential and kinetic energy stores of the particles in an object. Number 2, kinetic, the energy due to the movement of an object. 3, chemical, so this is energy stored in the bonds of chemical compounds like atoms and molecules, for example, foods and batteries. Gravitational potential, energy of an object in a gravitational field like on a planet such as Earth. Elastic potential, energy in a stretched rubber band or a stretched compressed spring. Electrostatic, energy between charged particles. Some examples are protons and electrons. Magnetic, this is energy due to forces caused by magnetic fields like 2 bar magnets brought close together. Lastly, nuclear, so this is energy that can be released by atomic nuclei in nuclear reactions such as fission and fusion. Now we're going to look at some of these energy stores in more detail. Thermal energy store. As temperature is related to the average kinetic energy of the particles in a substance, then the more thermal energy an object has, the hotter it is. So we're going to consider 2 cylinders of lead that we can see below. The one on the left is hotter than the one on the right. The cylinder on the left is going to be the one with more thermal energy as it is hotter. Moving on to kinetic energy store now. Any object that moves has kinetic energy. So we've got a car. Initially it is stationary, so it has no kinetic energy. As it moves, it possesses kinetic energy. And when it stops moving, it loses this kinetic energy. Chemical energy store now. Some common examples are batteries and food that have chemical energy contained within them. Moving on to gravitation potential energy. Anything with mass that is in a gravitational field, like here on Earth, has this type of energy. So we can also have gravitational fields on other objects in the solar system, such as the moon, other planets, and the sun as well. So we've got an apple which is standing at a height above the Earth's surface, and because the apple is in the gravitational field of the Earth, it possesses gravitational potential energy. Elastic potential energy now. So if you were to stretch the bow below, that would store elastic potential energy in the string. So initially the bow is unstretched. Once we stretch it, that stores elastic potential energy in the string. Electrostatic potential energy store. So if you have 2 masses with charges, we bring them close together, they will possess electrostatic potential energy as shown below. So we've got 2 positive charges. Magnetic. So if we have 2 objects like magnets, we bring them close together, they will have magnetic potential energy stored between them. So we've got a couple of bar magnets. We bring one close to the other and they will store magnetic potential energy now. Finally, nuclear. Energy can be released by nuclear reactions like fission. So we've got a nucleus below and we're going to split it up using a neutron. Neutron hits the nucleus, energy is released, the nucleus splits into 2 nuclei and we have some more neutrons released.